Okay, good day. This is your art math teacher, Sebisma. We are all back on differentiation. We are continuing with the first principle as we have studied in the previous example 1. We are coming to look at the example 2. Then we have the example 2 on the board which says that y equal to 3x plus 1 all over x. Now, how do we solve this? In this question, wherever you see x, we shall substitute x plus h over there, and then at the final solution, wherever we have h in it, then we substitute 0 into the function over there. So let's get to action and see how it is being done. So our dy over dx will be equal to the limit of h approach 0 into bracket, wherever we see s, we substitute what we have over there. Then minus the same function again, which is 3x plus 1 all over x all over h. Now the next step is to expand this bracket over here. So we having dy over dx equal to the limit h approach 0. So we having 3x plus 3h plus 1 all over x plus h, 3x plus 1 all over x all over h. Now the next step is to find the LCM for this and this separately. So our dy over dx will be equal to the limit h approach 0. So the LCM for here will be x plus h. Over here too, that will be x all over h. Now this, we place it in the bracket, is over 1. So when this goes here, it will be x plus h multiplied by this. So we have x plus h multiplied by 3x plus 3h, bracket close. When this also goes here, to left it to 1, so plus 1. This is also over 1. So when this one goes here, it will be x multiplied by this. When x goes here 1, then plus 1. The next step is to expand this bracket. So our dy over dx will be equal to the limit of h approach 0 into bracket x times 3x will give us 3x squared plus 3xh. Then we use the h also to multiply, plus 3xh plus 3h squared plus 1 all over x plus h minus, over here to this, we multiply it out, give us 3x squared plus 1 all over x all over h. Now we can see that we have group of like terms here. So we have dy over dx will be equal to the limit h approach 0. We can add this and this, so we heading to 3x squared plus 6xh plus 3h squared plus 1 all over x plus h minus 3x squared plus 1 all over x all over h. The next step is to find the LCM for this and that. So our dy over dx equal to the limit h approach 0. So the LCM will be x plus h all over x all over h. Now So this goes here, it will left with x, so the x will multiply all these. So we have x multiplied by 3x squared plus 6xh plus 3h squared plus 1. When this x also goes, the left with x plus h, we will multiply this. So x plus h multiplied by 3x squared plus 1. Now we have to expand the bracket we have, so our dy over the x equal to the limit h approaches 0. This time this will give us 3x cubed plus 6x squared h plus 3x h squared plus x minus this time this will give us 3x cubed plus x plus 3x squared h plus h all over x plus h multiplied by x all over h. Now the next step is to use this negative to expand these brackets we have over there. So we'll be getting dy over the x equal to the limit h approach 0 into bracket 3x cubed plus 6 x squared h plus 3x squared plus x. So we use the negative to expand, then you'll be getting minus 3x cubed plus x minus x minus 3x squared h minus h all over. This is divided by this, so when we divide it, we are getting x squared plus sh all multiplied by h. So we can say that we have like terms, so this will cancel this, this x also cancel this, so we have 3sh squared minus this minus h. So our dy over the x will go to the limit h approach 0 will be 3x squared h, this minus this will give us 3x squared h plus 3x squared minus h all over x squared plus xh multiplied by h. The next step is to factorize the h out. So our dy over the x will be equal to the limit h approach 0. H will be out, it will left with 3x squared plus 3xh minus 1 all over x squared plus xh all over h. So we can say that this h will cancel what we have here. Now from the rule we said that dy over the wherever we see h, we substitute what? 0 over there. So when we substitute 0 here, we are adding dy over the x will be equal to the limit of h approach 0, 3x squared minus 1 all over x squared. So now the denominator plays for all of them, so this will cancel this, it will left here. So our dy over the x will be equal to 3 minus 1 all over x squared. So this is our differentiation to the respect of the first principle. This is your hard math teacher, Sir Bismarck. Just if you love the lesson, just like and subscribe. Thank you very much.